So for those joining us on YouTube, digital forensics is basically like criminal forensics, where you have like a scene laid out in front of you and you're trying to determine information based on that. So it could be a memory dump from an infected machine, or it could be some encrypted data that you're trying to decrypt, right? There is a subset of this called Steganography, which is basically hiding codes in plain sight, which is our first challenge here. And I'm curious if Tim can figure out exactly what this one is, because I swear I've told you about this one before.
All right. So, pretty obvious. Look at the board. Look at the pillars. Look at the water. What am I looking for on the water? I should really zoom in or open this in an actual good editor. Can I seriously not zoom in this piece of crap? All right, I'm gonna open this in an actual good editor real quick.
Nice test top, by the way.
Thanks. What am I opening it with? Let's go that one. Yep, there we go. Look at the glasses. There we go. For those who can't see, it spells out swag. And for anyone that doesn't know, this is a picture of me on holiday from a little bit ago. I think it's about 2 years ago now, when Daniel asked my girlfriend to acquire some embarrassing photos.
She wasn't meant to... All right. Anyway, so that's kind of the obvious thing here. Follow the clues. Like, it's very obviously there's something, and you've all seen the memes. But notice that this isn't exactly just a photograph, because there is a weird white box at the bottom. And maybe that's there for a reason.
Oh, what if we try and get rid of the white box? How can we get rid of the box? What do you reckon, Dan?
I reckon you were pretty close before with those sliders.
Daniel, you might want to try threshold.
Threshold. Which one's threshold?
I don't know if Paint.net has it, but GIMP does.
So what does threshold do exactly? In GIMP, while I'm downloading it.
What it does is it has a point. You choose a point on some color, and then anything below that gets turned to black. Anything above that gets turned to white. It's really good in these situations where you have like a really faint color difference.
If anyone is familiar with Adobe, Adobe has a similar thing for not so much its own tool, but a lot of tools like their eraser or their paint bucket have threshold parameters which do the same thing. Basically, it's a threshold of how similar to the current pixel do I have to be in order to also override that pixel.
I reckon that magic wand might. Yeah, there we go.
Hey.
Got it.
That also works.
All right, so I set the tolerance to 0 for that one, so it only selects things that are the exact same color.
So maybe try a percentage of 1.
No, one still works.
Okay, I'm gonna blame that one on Google's compression algorithm.
Most likely. All right. But yeah, as you can see when I was selecting earlier, you really can't see the color difference at all. Let's see just how high. Yeah, so even at 5%, it didn't select it.
So the reason for that is just because this is a common, like, simple CTF challenge that people like to do, where basically you make something very, very similar. So in this case, I basically made it just what's it called? I made it like one RGB value off white. So yeah, if you ever come across an image called Steganography, because people are really uncreative and they always use the name Steganography, try that.
So yeah. Someone mentioned in the chat that inverting colors could potentially have been an option. However, the color difference is so minute that it may have blended in even when the colors are flipped. You need one of those tolerance tools or something like that. All right. Oh, MonSec forensics.zip. This seems promising.
Wait, did that upload? What?
Yep. It's going to be a little bit to download.
How big is it?
2.1 gig.
Oh shit, it actually finished. Okay.
So that's going to take me a little bit to download. What about malware.exe?
Ignore that because that is the final thing.
Neat.
So, take a break for a second. How's everyone's day? This is a completely functioning workshop. Don't even worry about it.
What we can do in the meantime, actually, is we have a few Pico CTF challenges
True.
flying around to with forensics. So let's take a tackle on them real quick. If you guys don't know, Pico CTF is a pretty common CTFing site which has challenges from all around. I don't think we have a MonSec team set up at the moment that anyone's able to join. However, you can join in your own time, and they do have just tons of challenges on pretty much anything you could think of.
So Pico CTF limits each team to 4 people, which is the reason why we don't have a team, because we have like 3 teams already. So if you and a couple friends want to do it, highly recommended.
Perfect. All right. So we have a bunch of different Pico CTF challenges here. So I've never done these before. We do have the walkthrough there, but that's a bit boring. So I'm going to rely on hopefully either Angus or Daniel to be able to help me figure each of these ones out. So similar to what the flag we ended up with before was, we're looking for a flag in the format of, what is it, Pico CTF, and then some text in the middle there. So we essentially want to find that in each of our images. All right. So let's open this new one, go back into Paint. What is it? Garden.jpg. So there's nothing immediately available on the image itself. What do you guys reckon? Any suggestions? So this is the hint we gotten. What is a hex editor?
I think a good question to start with is, what is hex?
Yeah, so a hex is, well, do you guys know what hex codes are with colors? So hex codes, essentially, they define what each color is. So each color of each pixel. And of course, each image is made up of tons of hex codes. So we got to try and find we got to try and get something called a hex editor to look at the raw bytes of the file. So, do I have a hex editor installed is the question. Let's see.
I think your Ubuntu should have come with one. I think it's XXD from memory.
Oop, yep. That works. Sick. All right, so if we look at what I want to see into. If you guys haven't seen it before, by the way, this is the new Windows terminal. You can have a bunch of different stuff loaded onto it. It's amazing.
Yeah, have you seen the trailer for it?
It's
mint.
Such a good trailer. All right, so this is the hex of the entire image. This isn't that useful. All right, let's stop it there. So like I said before, we're trying to look for a flag of that format, which means we're going to want to try and filter that output. How would we filter the output? What do you reckon?
Grep.
Yeah, grep is amazing. I don't actually know how to use grep too well because I'm only just getting a grasp onto Linux in one of my units for like full-on Linux. So if we have a look at,
close.
I know,
like one word off.
I know. But yeah, so grep is essentially a regex application. Try and match as a pattern. So you'll see, pipe it into grep, and we are looking for Pico CTF. Oop. Nope.
I think
What
you
am
have
I
to
missing?
do -I if you're piping input.
-I. Yes, we are.
Maybe try just Pico, because you'll notice that the characters are broken up from the XXD output.
I think Pico's flag format has lowercase p and
Would using strings work?
A string should work. Strings is another, no, I only have a vague memory of it. So strings, yep. Oh yeah. Strings only prints the readable. Oop.
I think you can just do strings
and
whatever the file.
JPEG.
All right.
And put that one into grep.
Okay. Hey, there we go. So we finally found the flag and all of that. So we did strings to get all the human readable output, and then we grepped for part of the flag to try and find it. So we found the flag of Pico more than meets the eye. And just as so happens, the rest of the challenges have all downloaded. So now we're going to shift over into the rest of the forensic challenges. What did you put in these, Daniel? Jesus Christ.
So from this point on, hopefully, if all goes according to plan, you should only need the step 2 folder. The step 3 and 4 are redundancies.
Redundancies that take up almost a gig. Nice.
Well, of course, yeah. Cool.
Oh, I'm loving this already. All right.
So to give some people context, I work for retail, right? And retail stores are closed down at the moment because of stage 4 restrictions. So I got bored. That is my excuse.
Sure. All right, so I see you snooping. There doesn't seem to be anything immediately visible in the image. Let's bump up contrast background. No. No. Select a few things with the wand. Yep, turn that tolerance down. No. Doesn't seem to be. So Daniel's probably not lazy enough to do 2 challenges that are the exact same in a row.
I wouldn't put it past myself. But no, not in this case.
So another thing we can look at is the... There we go. So the metadata of the image. Each image that you take or edit will have some form of information hidden within it, or hidden alongside with it, called metadata. That tells you stuff about what it's of, when it was taken, what program is used to edit it, its size, things like that. And you are able to edit this if need be. And just like that, there's a second flag.
Yeah. So this is really like ridiculously easy to do on a Windows machine, which I assume most of you are using. But a few of you might be using Mac or even like Linux, Kali Linux, if you're trying to do a CTF. And I have found it really hard to find a good like desktop environment that uses that outputs this sort of properties the same as Windows would. But I have found some really good command line tools that do it. So as Tim is reading my mind and going directly to it, there is a tool called EXIF tool. That's EXIF tool, one word, all lowercase. You can download it just by sudo apt-get the name. And pretty much what this is it's a command line utility that just prints out the metadata. Doesn't care about the image. It knows exactly, like, it knows what a JPEG is. It knows what a PNG is. It will look for that metadata and just output it. And we can see here that it even says I was using Photoshop CC 2015. I was doing all this stuff, and that's exactly the time that I stopped modifying it. If you go down a little bit further, something really interesting, which I don't know why, in Windows, it outputs it as the title was MonSec Snoop Dogg, but EXIF tool reads it as the XP subject, and every other utility I found reads it as the XP subject. So I don't know what's going on. That's just really interesting.
Oh. All right. That was all that was there for that challenge, was it?
No, actually.
No.
So, you can close that. From this point forward, we don't need images anymore. That's sort of the basic sort of forensics challenges that you'll see. Majority of beginner stuff will pretty much just give you steganography or metadata or something like that. Let's take a little step into the bit more advanced. So Tim, do you recall I told you to download something called BinWalker?
BinWalker. I do indeed have that installed, I hope.
Do you know what BinWalker actually is? No. Cheating.
Didn't work anyways. All right.
Go.
So what is BinWalker, Dan?
BinWalker is basically a program which will take a file that you put into it, and it's a file carving tool. So it will take data and look at that data and then see this section looks like a JPEG, label it as a JPEG. This thing looks like an SQL database, label it as an SQL database. So this is really interesting because this tool is basically the go-to if you want to do any sort of forensics on like like malware that takes it, like that brings down its own packages, and it has its own file system and everything, right? Think like some super like North Korea type malware. This is the tool that you would use to sort of decouple that and see how it works. Or if you're more into the reverse engineering scene, this is what you use to reverse engineer firmware. So you can get like, for instance, you can get like your DVD player, right? Your DVD player, everything's connected to the internet. It's connected to Netflix. It needs updates. You download those updates. Well, those updates normally come as a .bin file. How do you know what a .bin file is? How can you decompress that? How does the system know? BinWalker. And another fact that's really interesting is that you can actually hide data within JPEGs. So the way the JPEG format works is it has an identifier for the start of the JPEG and an identifier for the end of the JPEG. So when something is reading a JPEG, so for instance, when your web browser is trying to display a JPEG, or when your Photos app is, it will see that start, it will pass everything else, it'll see the end, and then just quit. But if you put data after that, to the file system, it still looks like a JPEG, but to like a to a viewer, it doesn't even look. It still looks like a JPEG as well. It doesn't care about the other data. So to the file system, it looks like a JPEG. To the programs, it looks like a JPEG. To BinWalker, if you would like to run BinWalker on the secret, it looks like this.
Yep.
God damn it, Tim. You had one
I
job.
swear I installed it.
Yeah, it's fine. It's only like 100 meg.
Ooh. Am I spelling it wrong?
No?
Is it not a Kali thing, or?
It's BinWalk, not BinWalker.
Hmm?
BinWalk without the ER. I think
Oh,
so.
BinWalk?
Yeah, try that.
Sick.
Oh, yeah,
Alright.
it is. Sorry.
I should have that then, because I did install everything you asked me to.
Yeah. Sorry. My mistake.
Yeah, there we go.
It's called BinWalker, but it's BinWalker now. Or at least I call it BinWalker. It's the Mandela effect, right?
Yep.
Cool. So what you see here is it's identified the image, the TIFF image data, which is the JPEG, and then it sees a zip archive. And then it has something else below it, but we don't care about that just yet. Right now, what I would like you to do is run exactly the command you just did then, but with a -e on the end. So the -e parameter is basically just saying, maybe put the -e between BinWalker and secret.
Yep.
Basically, -e is -extract. It will look for it and it will try and output everything that it finds. And can you ls that directory?
Yeah, there we go.
Yeah, there we go. Cool. And then it'll dump it into this sort of folder and end it with .extracted.
Yep.
Cool. So in that, we see two files. We see a zip file and we see a PCAP. If you actually go ahead and extract that zip file, you'll notice that it is actually just the PCAP. For whatever reason, BinWalker is able to see that there is a zip file, but also see within the zip file, there is a PCAP, and then it just extracts both. Who knows? Anyway, so what is a PCAP file? A PCAP file is basically, it's a packet capture, hence the name PCAP. Packet captures, if anyone's done networking or anything, or if anyone's looked up how to hack on Google, this is probably one of the first things you've seen, is Wireshark and packet sniffing. Packets are basically just the fragments of data that we send across the internet to communicate with each other. So if you were to load up a program called Wireshark right now, you would start to see a bunch of data, and that's the data that your computer is sending to Zoom, or your computer is sending, like Zoom is sending back to you. In this case, this is just a capture that I have gotten. I have basically listened for data, and then I have saved that data. And it's really nice. So, Wireshark is a really, really nice thing that actually gives you... it doesn't only pass, like it doesn't only save the data, but also passes the data. So you can actually see exactly what it's doing in human form. You'll notice that a lot of this is purely just TCP connections, which is transferring like raw data. And that is because I transferred a gigabyte file, so all the interesting stuff is at the top. So has anyone had any experience with HTTP before? I sure hope so, because you got onto this. Okay. HTTP is the protocol that runs the web. If you came to our crash course last week, you would know that it has sort of this get and post request, get and response rather, or like a request and a response sort of format, where you request from the data, I want this, and the data sends, okay, here it is. So we can actually see this happening before our eyes. If you look at the green sort of text here, the first one is get / which is the root directory or the index page. And the server transfers some data and then says the HTTP 200 OK, which is the response. And that's after, so everything between that is the data transfer saying, here's the web page. After that, a little further down, we get favy icon or fave icon or whatever it's called. And you'll notice that we get some issues in this one, and we get a 404 error because I'm lazy and didn't actually implement that. And then we get an interesting one where we try and get secret.txt. We transfer some data, and then we get a 200 OK. So from this, we can see that someone has tried to get a secret. And we have all this data here, so surely we can get the secret. And I'm curious as to if Tim knows how to do this.
I did at one point in time. I'm not sure if I remember how to, but who knows? Hopefully, hey, there we go.
Yeah. So this is something that's really interesting. Is that each one of these packets, right? You can, like, in the lower half of the screen, you can just see the hex data, which also means that you can, like, scroll through the particular protocols, scroll through the particular frames, and see what it is. I didn't actually think of that, so that wasn't the intended solution.
Oh.
So the intended solution, and the way you would do it for more complex things that don't take a single packet to send, is if you go up to File, you go to Export Objects, and you go to HTTP. This will look through all of the packets, and it will see, oh, a file is downloaded here. Here's that file. And then you can click Save, and you can open the text file, which is what I intended to do. Didn't quite work. Damn you, Tim, and your ingenuity.
Blind guessing, gotta love it. All right, got it.
Cool.
All right, is there anything else hiding in that?
I don't know, Tim. Is there anything else hiding in that?
It's gonna be a long scroll down for both of us.
So what are you actually scrolling past?
Bunch TCP requests.
What are those TCP requests doing?
Transferring information between the server and the client.
And do you know what that information is?
Vaguely.
Vaguely.
It's been a long time since 1047.
Okay. We can see, before he scrolls all the way down, that there is another GET request here. So this was my attempt of showing something that was bigger than a single packet. It looks like Wireshark isn't playing nice with me tonight, but you can see that the user has downloaded something called windows.raw.zip. This is basically like, yeah, this is another file. If Wireshark was playing nice, it would actually allow us to save it like it did with the text file, but unfortunately not. I've tried for like 2 hours, I can't figure it out. So
Okay.
if we move on to the step 3, actually, no. In your terminal, go to step 4, because this is the last part. I forgot about that. So that's sort of like a network analysis, right? That is if you were working as a blue team person, so you were the IT guy protecting against hackers. That's the sort of thing that you would do. Oh, we've got an intrusion on this device. Let's like look at all the packets that device is sending out, and let's see what sort of data is being transferred. Very often you will get things like malware scripts. Like the script that the malware needs to run will just be downloaded from a website or downloaded from another computer. And if you listen quietly enough, you can pretty much just download that yourself without having to interact with the malware directly. Speaking of malware, if we have a look in this directory, we have a few different things, including the windows.raw and the windows.raw outside of its zip file. And did you install Volatility by chance?
Yep.
Wonderful.
I'm going to need to... Actually, I'll just transfer the GitHub files over to it.
That works too.
Where did I put it?
Wait, so did you actually run the setup?
Yeah,
No.
kinda.
That's a no. Okay. Tim. What am I going to do with you? Okay. So... yeah. So for this last part, we are actually going to... Oh, you actually downloaded both of them. Okay. Cool.
You didn't say which one specifically to use, in my defense.
They're literally the same thing. Just one's written in Python 2, one's written in Python. Anyway, so for this last part, this windows.raw is actually a memory dump. It's a memory dump of, well, presumably a Windows machine. So basically what a memory dump is imagine you took a snapshot of a computer and then you just took what's in its RAM at the moment. And that's a memory dump. You're dumping the memory. This is, again, really useful for forensics, especially when dealing with malware. And the tool that we will be using for this last part is called Volatility, which is a really awesome, really powerful tool with really terrible documentation. There are actually 2 versions of Volatility, both by the Volatility Foundation. We have Volatility and Volatility 3. What happened to Volatility 2? Nothing. It never existed. Volatility was originally written in Python 2.7, and when Python got depreciated, there was a move to Python 3. They started development concurrently with the other Volatility, so they put it in its own repo, which is Volatility 3. Doesn't really matter which one you get at the moment. But in future, Volatility 3 will be the one supported. So, for the best experience with Volatility, you can just sudo apt-get or pacman or whatever your package manager is, except this will only come with very limited profiles, and we'll see why that's important in a second. Just get it from Git. It's easier. So you basically just git clone the repo, you get this folder, you type /setup.py, and then I believe it's -- install, I think.
Yeah, it doesn't mention that in the quick start, surprisingly.
Did it work though? Or is this just like, okay.
I think we just go from here.
Volatility or Volatility 3?
3 at the moment.
Okay. Huh. All right. So Volatility 3 is different and it's actually portable. You don't need to install it. Cool. In that case, just Python 3 vol.py, which is volatility. You pass in the file you want to analyze with -f, and then we want to analyze windows.raw. And if we just go ahead and run that.
Yep. Which plugin am I running? Which plugin am I running?
Right. It doesn't just analyze it out the gate. You do need to tell it what you're wanting to do. Run a plugin called image info. One word, all lowercase.
Just like that?
Yes. So this is your image info. What is going on? What? Okie dokie. Why are... See what I mean by terribly documented?
Oh,
This
it's
is-
literally just regular install. Neat.
Oh my god. Whoops.
Now we get to look like real hacker men.
Oh yeah. Run it as sudo.
Yeah. Classic.
Setup.py.
Yep. Totally didn't have a mental blank.
It's fine. We all saw it.
It passed at that time. Yep, got it.
Oh.
All right, and then what were we doing? We were doing Python.
So you don't need to do Python volpy anymore. You can just refer to it as volatility.
Oh, sweet.
Yeah, because it's installed on your system. And I don't know how to get rid of it, so
I'm stuck with it now.
pretty much.
Volatility F Windows raw.
Damn it. What if you just do Python vol.py? See if it has the same structure.
Yep, I'm not in the right directory. That would help. Promising.
Of course it does this. See, guys, this is why you never do live demos. Okay, just cancel it. Cool. Should we just switch over to mine?
Yep, let's go over to yours.
Okay, let's see if I can do this from
Proper live demo.
Oh yeah. Cool. So, switching over to my. Oh, hey, I have the chat window. Nice. Cool. So if we go into. Yeah, go away. Cool. Can you guys see the chat window out of curiosity?
Nope.
No?
Blurred out.
All right, cool. So, if we look at volatility, we pass in the windows.raw, which is the memory dump, and we go for image info. What is meant to happen is that it goes through, it looks at this just chunk of data, chunk of data, and it tries to figure out what sort of system it came from. Because from Volatility's perspective, it doesn't know if this is Mac, if it's Linux, or if it's Windows. We can guess that it's Windows, but Volatility doesn't really know that. So what it does is it uses profiles, specifically profiles based on this KDBG. No clue what that actually is, but it's some sort of signature. So yeah, that's fun. And it can take a little bit just because this thing is a gigabyte in size.
So that's what you made me download.
Yeah, this is the problem. So has anyone actually done anything to do with sort of how computers work? Like what, 1048? How, like the von Neumann architecture, anything like that?
1047.
Was that 1047?
Yep.
What was 1048?
C.
Oh, okay. Well, it's a similar thing, memory. You can speak. No? No? Okay.
Speak, type in chat, put a thumbs up.
Or just tell me how beautiful I am against this solid brick wall that is actually freezing. Don't do.
Yeah, I think a lot of us have blocked 1047 from our memory, to be fair.
Yeah. Okay.
Because what, all of you guys would have done it when Abdul Khan was a lecturer?
Yeah, he's still lecturing.
Oh, cool.
Yep.
That's fun. Yeah. Okay. Has anyone here done FIT 2100 operating systems?
Yeah, I'm doing it this semester.
Yeah? How far through are you at the moment? I mean, you're in week 1, so like...
Yeah, we really haven't done much yet. I think we've gotten one lecture and we've gotten a brief introduction to C.
Okay. So what you'll be doing later in this semester is you'll be going over sort of processes, the difference between processes and threads, and as part of that, you get to learn about the process tree. And basically, the way modern computers work is because everything needs to start somewhere. And how do you make a computer do everything you want it to when you have to start somewhere? Well, you start at something called a zygote, which is a biology term. But in this case, it's a very simple program, which it's pure, like the only thing it's meant to do is to start other programs. So that has something called a PID, or a process ID, and that is PID 0. That's the zygote. And from that, it starts the memory management. And from there, you get into the operating system, you get into Zoom, you get into Word, Excel, PowerPoint, stuff like that. You can actually see your what's currently running through Task Manager or Top if you're on Linux or Mac. You can actually see all these sort of processes running, right? And you'll see that over here, each process has its PID. So that PID is where it is on the tree relative to the zygote. So how is this process tree actually like implemented, well, you need to keep track of where it is, and you need to keep track of when you add or create or destroy. So it has to be in memory somewhere. And I have to figure out how to get out of top again. What?
Q for quit.
I'm an idiot. Okay. Cool. So, this process tree exists in memory, and I think I can do PS tree to see the actual. Yeah, so this is probably a better way of doing it to visualize it. This doesn't give you the ID, but this is like how it all breaks down, because the system D makes KD makes the console calls ZSH, and then ZSH being my shell, I run the command PS tree, and then PS tree gets spawned from that. So that's sort of what's going on. Anyway, the point of all this is that the processes exist in memory, the process tree exists in memory. So if we go to our handy dandy tool of volatility, and we have a look at what it previously output, I'm an idiot. Let's run that again. Basically, if we have a look at the volatility output when you do image info, it will compare the image to what it knows, and it will try and guess what sort of operating system it was. This one is an exact match, so it shouldn't be taking too long, but it just means I have to kill time twice. Really should have thought of that. Anyway.
So what do we do with the info that we get from volatility?
What do you mean?
Like, what sort of info can we get from about the Windows.raw besides the operating system?
So volatility it can look at anything in memory. So what if you were looking at an image, right? And your computer just froze up, and you were able to get that RAM exactly how it is. Well, that image was loaded into memory, so you could get that image out. Similar thing with processes, and the reason I'm talking about the process tree. All of these processes are loaded into memory. If I took a snapshot exactly when, if I just took a snapshot right now, and I ran volatility on it, I could see that zoom was active. And the goal is to, in this case, extract that out of memory so you can get just the raw binary. Or the raw image or anything like that. It's also really useful if you get really deep into it and you start messing around with the sort of internals of the operating system itself. You can find things like what kernel modules were loaded, what network connections were going out. If you have malware and that malware is communicating with the server, then you can see exactly where the server is just by looking at what was active at the time. Yeah. It's actually a really interesting tool, and if anyone has any interest in operating systems, or if you're doing 2100, play around with volatility, just because it's really interesting what it can do. And if you know what volatility can do, you kind of learn tangentially how the operating system works in order for it to do what it does. But anyway, enough stalling. We can see that this has suggested the profile for us, Win10x64_18362. This is, if we break down what this profile actually is, any guesses for what Win10 is?
Windows 10. Do I get an award?
You get a clap. Next, the X64. It's a 64-bit machine. And then this is actually the model number, or the version number, rather, of the particular Windows install that I was using to make this. But now that we know what profile to use, we can just throw that bad boy in, and we can see, if I just do image info again, it should take no time at all. Oh, it's still never mind. Don't worry about that. Anyway, the point of having these profiles is just so it knows exactly where to go, and it doesn't keep doing that really long process of trying to guess what it's looking for. Really useful. But yeah, now that we know the process, now that we know what we're looking at, if we do PS tree, which you'll notice is the same command I ran up here, we should see the Windows process tree. And we can see exactly what was running on the system. And it is quite a lot. These are actually the byte offset of where this executable exists in the sort of file, in the windows.raw. But because each process keeps an identification of itself and its parent, it can reconstruct the tree. So it can see that WinInit created services, which created all these sort of things. And then, like, further down, we can see things like, where is it? Yeah, so we can see things like the WinLogon, which is the executable which lets you log in, creates a user, and that user is looking at explorer.exe, which is your file system, basically. And we get a very interesting piece of software running. So this, you can see, like, just from this alone, you can see that malware.exe was run from Explorer. So someone double-clicked on the executable to launch it from Explorer. If this was instead something like edge.exe, well, you can guess that they infected the Edge browser and made it run that. If you do any sort of pwn challenges, you can, if you ever do a buffer overflow and then execute shellcode, which executes bash, this is how it looks in memory. The infected process and then the malicious process. If we actually want to get this malicious process out of memory, we just need the PID, which is, in this case, this. And then we... what is it again? Nope. Okay, this is the command. Basically, we use the plugin called procdump, or process dump. We pass in the PID, which is 3364, and then we put in where we want to dump it to. In this case, we just want to dump it into the step 4 configure, like the step 4 folder that I'm in. So we just put dot. We run that. And we get this executable. So executable.33464.exe is exactly the same as malware.exe. If we actually have a look, there it is. So does anyone want to guess how we go about analyzing this? Or actually, Tim, do you have any suggestions on how I should analyze this executable?
Run it.
Sure. Okay. So the reason that worked, and I didn't know this happened, I have something called Wine on my system, which is Wine is not an emulator. Basically, Wine is a program which lets you run Windows programs on Linux. In this case, apparently you can just run exes and it knows what it's doing. What's meant to happen is it's meant to give you an error. And then I say, oh, try this tool. It's called Wine. It's great. You run it, in this case. If it was actually malware, maybe don't run that. In this case, it's fine because, you know, I'm lazy and just put a while true loop in there. But similar to our first thing, if we were trying to find something, we just use the command strings, we get this executable, and we can see all of these readable strings. Fun thing to note, here is the flag, which is, this is my final form because this is the last step. But also, fun fact, executables actually take memory from, like, it takes information from the people who built it. So you can see here that we have a file path, which is users, new, documents, playground, MonSec forensics, release, and then this. This is actually the file that I made to compile it. Well, it's one of the files that in my sort of code base. So if you do get sort of exes that are very crudely built, you can actually find information about the people who made this malware. And potentially that could be used later on in something like a court case. Who knows? But yeah, that's pretty much it. We've gone through, what was it? The first one was Steganography, hiding things in plain sight. That was the contrast sliders. Then we went over image metadata, so EXIF tool, which is how you see metadata, or in Windows case, right-click properties. Then we went over Wireshark and how you break my challenge, because it's so simple, or rather how you extract files that have been downloaded. And then the last one was a little bit of a taste of the volatility and memory dumps. So yeah, hope you guys enjoyed. I think I'll pass off to Tim now.
All right. Thanks for everyone who stuck along. It was a bit of a longer one, and our crash courses have been a little bit longer because we've tackled so many concepts. But we do appreciate you sticking along. We hope you enjoyed the slightly different format. In particular, we would love it if you would fill in the survey just to let us know what you actually thought of it, if you preferred this over our normal way of delivering information, or if you have another idea which you'd like us to try out. Otherwise, next week we should be running a crypto workshop by Leo Whitehead, who is currently in this chat. Other than that, that should be about it for today.